Okay, good afternoon, everyone, and thank you for joining us. I'm Desi from Clean Air Partnership, and today with me on the call are Esther Van Eeden, Jamie Dabner, and Sarah Borde, and I will introduce them shortly. But first, I wanted to start with land acknowledgement. Clean Air Partnership is a Toronto-based organization, and we acknowledge that the stolen land on which we operate is the traditional territory of the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. At CAP, we recognize that many Indigenous peoples are particularly vulnerable to climate change and will be disproportionately impacted by its effects. Through our work, we are committed to disrupting ongoing approaches to climate governance that reproduce settler-colonial relations and systematically exclude Indigenous peoples from policy making. I also wanted to share a short video with you so we can learn something new, hopefully.
A word you probably pronounced wrong your whole life. Everyone pronounces it kayak, but it's actually harak. Harak was an invention made by the Inuit and it was used to travel and hunt. Foreigners didn't know how to pronounce harak, so now it's kayak. Did you learn something new?
I hope we learned something new. Moving on to one of our resources, the Municipal Climate Decision Calendar, which provides a central platform to share information about upcoming council and committee meetings from across municipalities in Ontario and GTHA. And I'll share the link shortly in the chat. So if you're a municipality, you can submit your activities and meetings, or you can send email to us and we will be updating this decision calendar. Lastly, on our upcoming CAP events on March 16, we're going to talk with Brian Kelly, and he's going to share about his decarbonization journey. And on March 30th, Nature Canada are going to share about their program 2 billion trees. I'll be sharing link how to join this event shortly in the chat as well. But now I wanted to introduce our guest speakers. Esther is a certified passive house designer with extensive project management experience and provides technical as well as strategic direction for all KMAI's passive house projects. She had successfully led interdisciplinary teams across the UK, South Africa, and Canada over the past 11 years. Her project experience includes residential, retail, corporate, government, civic, healthcare, educational, high-rise residential, and hospitality fields. Jamie Dabner is the sustainability team lead for the Toronto Design Studio. He oversees a comprehensive suite of services aimed to reduce whole life carbon for building projects. Mechanical engineering design experience and a deep understanding of the building industry allow Jamie to provide practical sustainability-focused advice to clients and project teams. And Sarah is the manager of capital project at the YWCA Hamilton. She became interested in passive house during the work on the Putman Family construction project and participated in the passive house training, which led her to join the board of Passive House Canada in 2021. Without further ado, I am passing it over to Esther. And while she's sharing her screen, I wanted to remind everyone to ask your questions in the Q&A box, and we will be answering the questions after the presentation. Esther, you can share your screen.
Can everyone see this?
Yeah, thanks.
Yeah.
All right, perfect. Sarah will start us off and then I'll jump in with the technical passive house stuff.
Thanks, Esther. So good afternoon, everybody. Thanks for joining us today. So today we're going to talk about the YWCA Putman Family. It's located on Ottawa Street in Hamilton, and it opens its doors in summer 2021. It's currently at full occupancy with 50 women and gender diverse folks with their children living in the building. So the YWCA provides supportive housing to the tenants of the new facility. There is support available 24/7 in the building. Additionally, there's a wide range of programs hosted in the facility for the community members as well as for the tenants. There's an active living center, a women enterprise center, a youth hub, and a skill development and training program. There's also a common area on the 6th floor that's exclusively open for the resident and the YWCA staff, and it's mostly used by the people living with disability in the building. Back to you, Esther.
Thanks, Sarah. So I'm going to start off my section of the presentation by talking a little bit more about the client brief and the architectural side, as well as the technical aspects of Passive House, what it is and what it aims to do. So the first bit, we're going to talk a bit about the architectural side, and then we're going to jump into the specifics of Passive House. So yeah, as Sarah said, this is located in Hamilton, Ontario, and it's actually the first mid-rise full precast concrete passive house building in Canada. And it's about 5,000 square meters. And it has the residential component, as Sarah said, that services the 50 units, but then it also has 2 levels for podium programming and stuff like that. So the aim of that was to make the space more flexible and more accessible to the wider community so that they can have spaces to run community programming, seniors programming, things like that, which Sarah will also discuss a little bit more in detail later on. So yeah, it's a mixed use building, and then it has the amenity spaces on the ground floor, the basement, but also a residents only amenity space on the 6th floor. It has some garden space around the outside, and then most of the activities, like we said, take place on the ground floor and in the basement. From the client side, we had 3 very specific criteria to meet as an architectural team. And the most important one was that the building needed to be made out of a durable material, something that would not easily degrade. And then that material had to come from a local manufacturer, and it also had to fit into the historical context of Hamilton's industrial past as a steel town. So that was the architectural side that needed to be satisfied. And now we're going to jump into the technical passive house side. Before I jump into it, I don't know how familiar the audience is with Passive House, but I'd like to start with a disclaimer saying that Passive House, the word house comes from the German, and it refers more to a building than necessarily a house, and it is applicable to any structure. So any structure and any scale. So we can do it on single family homes, or in this case, on a bigger scale building like the Putman Family Y. So Passive House has a couple of basic principles, and they're summarized in the graphic here. The first one is that you have to have a very super insulated building envelope. So the first way to do that is to physically just add more insulation to your wall, roof, and floor assemblies. And then secondly, you have to make sure that that assembly is airtight. So normally from the inside, any joints are taped and sealed, and any penetrations require additional insulation and sealing as well. To maintain the high performance of the envelope, we also install triple glazed windows, which provides a much better buffer to the exterior elements as opposed to single or double glazing. And then we also look at the form and the orientation of the building so that we can make use of like what we call free energy. So what's available from the sun, we like to capture. That's also where the triple glazed windows help again, because they help keep the cold air out, but we can take that solar heat from the sun and use it in our building. What's shown in orange and gray there is what we call energy recovery ventilators, or you also get heat recovery ventilators. What we used at the Y specifically was an ERV, so that captures the moisture as well as the heat in the building. And it essentially captures what we can reuse instead of just pumping it back out to the outside. And then lastly, in our design, we also make sure that any junction, so if it's a foundation wall to the exterior grade wall or a parapet detail, all of those are designed very specifically to make sure that our insulation runs continuously and that we don't lose additional heat at those locations. And then we added that last one in there. It's not a specific passive house principle, but it's something that we found very, very useful in this project, is that most of the team was trained in passive house, and that just made the coordination a lot easier. So the passive house standard was actually invented in Canada in 1970s and then refined in Germany. And what the German physicists that kind of turned this whole thing into a standard aimed to do wasn't to create an energy standard. It was to create the most comfortable, healthiest house for an occupant. And the massive energy savings can almost be seen as like an unintended consequence to this process of him. And that's what's shown in these pictures here. So as an occupant in a building, we actually get uncomfortable very easily. And that comes from stuff like single glazed windows. You'll normally feel that a window is cold. And if you sit, even if it's like a foot or 2 feet away from a window, as soon as you feel that change in temperature, it can be as little as a degree or two, you'll go and turn on the heat, or other way around, turn on the cooling. And that's what drives all this additional energy loss in buildings as well. So for the Y, to achieve passive house certification, we had to achieve very specific performance values for the assemblies. And I've listed them here, showing the passive house values on the left and what would have been SB10 values on the right. And what we did post-construction was evaluate where we would have ended up if we had followed the standard code values. And when we break it down like this, you can see the massive difference between the R values in the assemblies. And what this turns into is if we isolate the space heating demand for a building, the Y's space heating demand was around about 12 kilowatt hours per square meter per year. And if we had followed the SB10 values, it would have been 3 times as much, around 37 or 38 kilowatt hours per square meter per year. So it really makes a big difference, these independent values. And going back to the passive house graphic, the way these different values and assemblies interface with each other is also evaluated in a passive house to further mitigate the energy loss. That space heating demand, however, is only focused on the operational energy. And although the carbon conversation wasn't at the forefront of what the building industry is focused on when we started the process of the Y, we did want to have a look at what would have happened and what we could have done differently, considering general or whole life carbon emissions. So as I said, when we started this project, we needed to choose something that was a durable material. And initially, this building was going to be a cast-in-place concrete building. And here you can see the total life cycle analysis, the carbon emissions for the 3 structures, cast-in-place shown in green. And then the precast concrete, what we ended up with, is shown in the blue. So it's about 3% better. And then about 12% better if we went for wood construction. What I'd like to highlight, though, on the slide is that even if we did want to do wood construction or CLT, things that are a lot more prevalent today than it was in 2017, 2018 when we started this, is that the location and programming of the site still didn't allow us to do wood construction. So code at the time didn't allow a building of our size to be constructed of wood completely. And then on the site, we also had very poor soils. So we needed to correct and mitigate that situation. So if we had done wood construction, we would have had to do most of the podium levels in concrete anyway. And as I said, wood is a lot more susceptible to degradation, and it wasn't the right choice for this project. We then went a bit further and compared if these three structures were to be constructed, what are we really looking at if we consider carbon emissions from the embodied carbon, as shown on the previous slide, and then the operational side. And what we saw is that it doesn't, like in the analysis, it doesn't really matter what the structure of the building is. More than 40% of your whole life carbon is still coming from your operational energy. And that's the criteria that Passive House attacks, and that's the criteria that it minimizes. So Jamie will share a slide later on, but Passive House can reduce your space heating demand by up to 90%. So considering all these technical aspects that we had to consider and think about, this project showed us that the only way to achieve these criteria and these outcomes is to have an integrated team. And that is what was the most important for us in this project. So obviously it required a very high level of coordination right through the design. And what that meant is that more people were actually part of the design discussion. So we were very lucky with the Y. We were able to have the CM on board as part of the design process. And then what also made a big difference is that we were designing with the mechanical engineer, the contractor, and the manufacturer from the get-go. And the way we did this was we used a lot of technology, but it's all things that are common in today's time. So everyone uses Revit and CAD in the industry, but the way we used that technology was to integrate it into our process where we would coordinate every week. So we wouldn't do the typical design where the architect team passes it on to the mechanical designer, and then there's a little bit of coordination to see that it all works with the structure. We did weekly design uploads and coordination sessions, and then we used a plugin called Revitso for Revit, where you can actually do class detection between the architecture, the structure, and the mechanical design to see if there are any penetrations that we haven't accounted for, or any structural items that interfere with duct runs, issues like that. This is just a photo showing one of these meetings. So we call them service coordination meetings. And after we completed the design drawings, we got everyone around the table to walk them through page by page. So you'll see here as well, we have the Passive House certifier on the team as well, and then the entire design team. And it was actually in one of these meetings that we discovered that we couldn't accommodate the crane we needed to get the precast panels onto the building in the way that we needed. So by looking at how we could change the panel size and alter the structure slightly, we were able to go from a tower crane to a mobile crane that was provided by the manufacturer, CourseLab. And that really saved a lot of cost for the client that we could then use in other places in the building, or go back to programming and what the client is able to provide to their community. So our biggest lesson learned, and Jamie will expand a bit on the lessons learned as well from a design side, and Sarah from the client side. But the biggest lesson that we learned was coordination, coordination, coordination. And for a Passive House specifically, we really learned that the mechanical design has a much bigger impact on the way we design these buildings. And you have to take a much more holistic view of how these buildings are designed and the process we follow than what we would do for a typical code-built building. I will now turn it over to Jamie, and he'll dive a bit more into what we did on the mechanical side.
Great, thanks Esther. You just had this one. Okay, we'll just go right by that. And okay, very good. Thanks, everybody. So if we go to the next slide, it's the one where Esther mentioned 90% space heating reduction. Really, that's passive house against an average Canadian building. So not necessarily a current, 2023 code compliant building, but sort of against the Canadian average. The passive house buildings are so much better performing. And really what we do with this kind of diagram is try to focus in on the design drivers. So obviously, space heating and ventilation, that's the first box here. That's what we attack first with our sort of design look at how to do a passive house building. And then we're going to get into domestic hot water. So I'll talk about those two today. Here's the ventilation. Basically, we're showing you the code required ventilation for OBC and of course ASHRAE 62 against the passive house rates. There's quite a bit of a difference for passive house. The way that passive house is designed actually is on 3 categories. It's total supply per person, total exhaust required based on the fixtures, the plumbing fixtures and whatnot in laundry inside the building, or inside the suite, I should say in this case, and the minimum air change rate. So of those, that's how you come up with this passive house requirement. So it's important to know that there's a little bit less ventilation happening, but it is constant and it does go to every single room of the building, of the suite. And so here's how we did it. Basically, we analyzed probably 5 or 6 different ways to do ventilation for the building. We looked at doing it in every single suite. We looked at doing maybe every 2 floors with sort of distributed machines. We looked at doing risers with machines on top of each riser, and we ended up on this strategy, centralized by occupancy. So one ERV on the roof does all the residential suites, and the other one is set up to run the program areas on basement and the ground floor. The idea here was keeping the penetration number low, so we're not going in and out of each suite twice. Less bridging, less sealing in the envelope, less thermal bridging, and keeping the floor to floors low. That saves money on the height of the envelope and the precast that needed to be done here. And we also specified a few different things like low leakage ductwork. So we had like less than 2% leakage. Sometimes it's around 5 on a regular project. So we're tightening the ducts here. There's other strategies that maybe got looked at for future projects. Here we only used the ERVs to do the energy exchange. As Esther was saying, they're desiccant dehumidification wheels, and they're only to do energy, and then the dehumidification happens inside the suites at a terminal fan coil. So every one of the suites has its own fan coil unit. That does mean though we'd used insulated ductwork throughout the building. Here's an example of a machine. At the time we had trouble finding passive house machines that were in this size range with the energy efficiency that was needed to meet passive house certified. There was really only 2 that we could use at that moment in time in 2018 when we were specifying. Here's the floor plan for the one typical suite. Just a couple things I wanted to point out here. We don't need the ductwork to go out to the perimeter of the suite. So while there is duct into every individual room, we don't have to blow air across the windows. The windows are triple glazed. The envelope is, as we saw earlier, like R50 walls or something like that. So less ductwork in the suite. The other thing that you see here that's a little bit different than regular projects is the outdoor air bypass. So the blue duct going into the back of the fan coil in this case actually can go right into the supply ducts, and you can turn the fan coil off in the shoulder seasons. So in this way, we could save quite a bit of fan energy and not need that fan to be running to circulate air within the suite. So you can just run the ERV on the roof. So it's like think of it like a free outdoor air ventilation bypass. Okay, so here's a section of the same suite. What I wanted to show you here is we don't have fan coils on the floor. They're actually in the ceiling. They're in the washrooms or the kitchens of this particular building. And then we put all the hot water piping in the walls behind the bathroom sinks and the kitchen sinks to really minimize the the length of run. In passive houses, you have to have quite a bit of insulation on chilled water, or sorry, on domestic cold and hot water. So it's about twice as big as a standard ASHRAE 90.1 allowance. So we did have to do quite a bit of extra layout for that piping, as well as the risers. You know, we normally don't have risers, so it's kind of putting the fan coils into the ceiling. You can save space, but you do have these risers that run through the building. Yeah, I wanted to just talk about the next thing is really domestic hot water. So if we attack the load for space heating and ventilation, then the next thing is domestic hot water starts to stand out as a big load. On this project, we actually, in 2018, we researched air source heat pumps. We looked into CO2 heat pumps at the time. They were newer technology, and they were asking a question. They were newer technology, and in our cold weather application, I'm not going to say they were unproven, but they were deemed to be a bit more risky for the project at the time. So, and also it was going to be single source for those types of units. So we actually ended up deciding to go with natural gas fired systems on this project in concert with the design team. We wanted to make sure that we're controlling first cost and also risk to the project, because there's quite a few new things happening on this project. And then we knew that this system would probably wear out within, say, 12 to 15 years, and there would be a chance at that time to electrify, still in the life of the building and the rest of the components that were going to be in there. So here's the hard part. Here's what we don't really like to talk about, to be honest, but it's good to share. This is what we're here for today, is like, watch out for these things if you're going to be designing and reviewing a passive house. The headers across the top of that cartoon that I showed you, where all the risers come up, they actually didn't fit inside the corridor on the top floor, because the pressure requirements for the duct is quite a bit lower, and it's more efficient in passive house design. It means they're bigger. So we actually had to drop a ceiling across the top floor suite. That was unexpected and caused some coordination issues, I'll say. If we were to do the design again, we probably would centralize humidity control to the ERV, as opposed to letting each fan coil pick up humidity control. It just would probably make it simpler. It would also maybe take some of the insulation out of the risers and make them smaller. As Esther was saying, rules of thumb don't really apply for buildings like this, like doing it the same way as a regular SP10 or a building code building that you've designed before. It's not like that. So you really have to do the calculations early and upfront, and the loads that show up are so much smaller than the engineering team is used to. It's actually hard to get equipment and fan coils that are sized correctly because the loads are so small. You can get it from Europe, but to have something in North America that's available is a little bit difficult. We also have a note here about the corridor sandwich. So that's really how the services go inside the corridors of each floor of the building. Of course, we want to keep the floor to floor low, and that's a constraint, but at the same time, there's lighting, there's refrigerant piping. In this case, there was control boxes that had to go into the ceilings of the corridor, and also ductwork. So we started to run out of room, and if we'd done a better job of setting that up with the entire team earlier in the project, I think we would have had less strife near the tender phase, I'd say. Okay, and then there are some code requirements about centralizing ERVs and having smoke dampers to address prevention of smoke going between suites. So you have to be careful with that and how to make sure that that's addressed in the design and coordinated with the electrical team. And then cross-contamination came up in our permit comments, just about how we're controlling that at the back at the ERVs. So it's something to watch out for. We did revise it, and the strategy went forward as planned, but it was a comment that came back and maybe wasn't clear enough in our original documents. Okay, cost transfer. So this is a really interesting slide because, do we not have the money on there? Okay, so the blue mechanical on the top left-hand side, active building means sort of standard building. And that's usually, we see that around 20% of the total budget of the building. And actually in a passive house building, and in particular at the Y here, it came in as tendered at 14% of the total cost. So in that, there's 6% of the mechanical budget can go towards, buying triple glazed windows, making sure that we're getting the excellent envelope that we need on this building. And I'll just leave you with this. This is, I was just mentioning 20% for a sort of code compliant building. We have access to some other numbers from a couple other projects that are passive houses around the sort of Ontario region. And you can see here, the Y did a little bit better than these other projects. They're bigger, so it's interesting to see that actually Hamilton probably has more, let's say, more training and more availability of capacity, and isn't pricing quite as much risk into the passive house strategies. So I'm going to leave it there. I'll pass over to Sarah.
Thanks, Jamie. So today I'd like to just talk about the owner perspective while talking about the Putman Family YWCA. So I'll talk about the passive house design versus the YWCA Hamilton vision, the funding with CMHC, the construction cost and operation cost, and finally the post-occupancy evaluation that we've done on the building. So as you all know, there's a climate crisis. So the more frequent, severe weather events brought on by climate changes have disproportionate negative effects on already vulnerable communities. And in Canada, the residential buildings account for 17.5% of all energy use. So reducing energy consumption is an important factor in reducing the effects of climate changes. There's also a housing crisis in Hamilton, which is reflected in the current vacancy rate sitting at 1.9%, and the average market rent for two-bedroom units, which had an increase of 5.3% last year, up to $1,438. So the lack of affordable housing in Hamilton is increasing every year. So as a developer, we ask ourselves, how can we create new affordable homes without worsening the climate crisis? To be true to the mission and values of the YWCA, the passive house design has been explored. In 2018, there was no passive house multi-unit residential building in Ontario. And the aggressive energy efficiency targets were appealing to the YWCA as it aligns with the vision of providing quality and resilient housing to the vulnerable population accessing our services. One of the fears that arises from this choice was the capital cost premium engendered by it. So multiple discussion and research in the available literature showed that the cost premium for this type of building ranges from 3 to 8%. So for a nonprofit developer, the lesser, the better. Finding the required capital funds to be able to develop a new project is a strenuous task. Obviously, the less we need, the better our chance to be successful in securing the funding are. But the offset of the capital cost premium is the much lower operation cost. So that's why we went with that design, that innovative design. So on developing the concept and working on funding, as you know, the contributions and loans from the federal government are available for developers. And one of the selection items is the energy efficiency of the proposed building. So it becomes an incentive for non-for-profit to build to the passive house standard to increase the chance to be selected for funding. But it's a competitive point system. So reducing drastically the energy consumption of the building allows for a maximum point in that category. Even though there is an incentive to build energy buildings to obtain funding, at the time of the YWCA application with CMHC co-investment program, no other project designed to the passive house standard have been selected or maybe even applied for. I'm not sure for that. So in order to for CMHC to actually consider the passive house standard eligible for funding, and the YWCA team had to make a case to provide educational details on the passive house standard and have experts explaining the PHPP models. So on the next slide, please. Thank you. On the tender and procurement process, I won't say much. it's been explained already earlier. I just wanted to highlight again that the construction manager has been selected early in the process. One of the criteria selection for the tender was the experience of the construction manager with passive house design. And what the YWCA team was looking for, especially, was this a sense of safety for tenants and a sense of community connectivity for users. So I put a picture of the lobby on the slide. It's because it's actually one of the preferred areas for the tenants to hang out. Each time I go in the building, there's always people on these couches there. So I think we achieved the sense of safety we were looking for. So that's something we are really happy with. So one of the recurrent questions that we hear often is, do nonprofit organizations have the capacity to overcome the construction cost premium? There's a lot of research available on various passive house projects. There's one article in particular that I really enjoy reading. It's dated from February 2020 from Zachary Semke. It's available on the Passive House Accelerator website. And it provides data on capital cost increase. So it's a research study on the low-income housing tax credit in Pennsylvania and the way the inclusion of the passive house standard in qualified allocation process induces an increase of the passive house development. So it actually shows that with time, the construction cost premium decrease compared to a conventional build. So the first year, the difference was 5.8%, 1.6% in the second year, and the third year it was actually minus 3.3%. So that suggests that the learning and innovation, by project teams drive the cost down over time. And it also became an incentive for developers to build better buildings. So acknowledging that the operational cost should be significantly lower has helped in the decision-making for this project. Because for the YWC, it means lower utility bills for tenants and for us in terms of operation cost. And the simpler mechanical system should also contribute to a lower maintenance cost of the overall building. So we don't know that yet. So I think it's safe to say that it has to be partnered. We don't know exactly how much energy we're actually saving, but there's a post-occupancy evaluation that includes monitoring that's currently performed on our building. So we'll know more later. So the final project, I wanted to say that even though the passive house design has to be simpler than conventional building, the Putman Family YWCA is a beautiful place. The finishes, the quality of the finishes are no different than in a conventional build. And it delivered more than what we expected. The massive doors when you first enter the building provide a sense of safety. The reception area is very bright. The building is very quiet. While you're in a unit, you can't hear the traffic outside. It's warm anywhere in the apartment. And also in terms of indoor air quality, in a pandemic situation, that was a plus, definitely, to know that there's a constant supply of fresh air that circulates in the building, which is filtered before being released in the unit. So that was an additional level of safeness. Finally, for the Putman Family YWCA, the capital cost premium has been calculated to be 3%. As I said earlier, we don't know yet for the operation cost, but the University of Toronto, in partnership with CMHC, is doing post-occupancy evaluation, including monitoring. So we'll know later on. There's another post-occupancy study that has been performed with funding from the Atmospheric Fund. The results are in, and there will be data published on the YWCA Hamilton website eventually. So the result of the study, so it's been done by Green Reason in 2021, and it reveals that both building residents and staff like the overall aesthetic of the Putman YWCA, with some specific comments noting the appreciation for the large windows, the lighting, and the perceived comfort of the building. Some residents noted that their bedroom were a little small, but comfort is perceived as an appreciated design element. From a facility side, the staff notes operating the building is easy to average, but find it difficult to maintain the HVAC system. We experience a larger than normal breakdown of some part of the HVAC system, with outside contractors sometimes challenged to find solution. Probably, as Jamie mentioned, it's quite new in Canada, so more training would be definitely a good thing, and also different equipment availability as well. Just a note on the windows, so they are beautiful large windows, but in terms of operation, it can be a little tricky to open and close, especially for people with any forms of disability. And for the tenant education, so we had an informative session explaining the basics of passive house for staff and for tenants, and we also distribute some educational material. We've done it a little late after the occupancy, so it's a lesson learned. Next time, for sure, we'll do that earlier in the process to avoid any unnecessary complaints. So to conclude, from the owner perspective, for sure, our next development will be a passive house building. We know that the additional construction cost is not a barrier. The complexity of the design or the certification requirements it's only a perception. And with the right team, it's very feasible to achieve the goal of building better. So if a non-for-profit organization can build to the passive house standard, private developers can and should as well. So it would be great to see other municipalities include the passive house standard in their building code to make it simpler and maybe to become an incentive for every development. So thank you for listening.
Thank you so much, Sarah, Esther, and Jamie. This was great presentation, and thank you for being with us and sharing this experience. We are now jumping to questions. If you want to ask your question verbally, raise your hand, but otherwise, I will jump to a couple questions that came here. The first one is I think Esther, is for you. You mentioned that the team that you worked with is like a PH, passive house trained. Is it easy to find contractors and with either experience or training?
In our experience, they are now very easy to find in Hamilton, I think because of this project. And Hamilton has been very progressive in adjusting some code clauses and stuff like that. They really try to remove the barriers to passive house. In some of the other municipalities around Ontario, we have struggled to find contractors that are already trained or have already built the passive house. But having said that, Passive House Canada, as well as some other organizations, do offer specific training for trades. So they call it a Passive House tradesperson. And what we're doing on our other municipal Passive House projects is we're requiring contractors to be pre-qualified based on their Passive House experience. It doesn't mean that they have had to build a building that has been a certified passive house, but if they have some sort of training, because there are also various options out there, you can do one-day trainings or fuller 3-day or 3-course training that involves a physical component as well. So yes, it is a bit difficult to find them, but it is getting better. People are catching up, and there's a lot of training out there available.
Right. Thanks so much. I think the next question is for you, Jamie. What was control scheme to ensure VRF condenser received required airflow?
Oh yeah, okay, good. Detailed question. So in this project, the condenser in mention here is an outdoor unit. So it's a refrigerant based unit that needs quite a lot of airflow. And there's several on the building. So I'm gonna guess that there's 6 to 8. I can't remember exactly, but they're located inside the building. So they're located in the mechanical space on the top of the building. And there's large louvers on 2 faces to allow for airflow. So there's different modes. There's a one where basically all the louvers can just be wide open and they can cool as if they're outdoors is the intention. And then there's another mode where the ERV, which is located next to the plenum in which they take air, can actually reject exhaust air into that plenum because it's warm coming out of the building. And so then the efficiency of those condensing units can go up by design, I guess, by having that warm air intake into that space. Then you can think about it like tricking the units into thinking that they're in a warmer climate, and they perform better because the sort of the delta T approach temperatures are different for heat pumps, and they're more efficient. So we did build that in, and that's a control scheme. You know, would we do it exactly the same way? I think the equipment in 2018 was different, and so it wasn't able to go as cold. So nowadays, like if you're specifying something currently, it's potentially could just be directly outdoors and still be able to provide the heating and cooling that we need. So it's a bit of extra complexity, but it was necessitated by the equipment selected at the time.
Thank you, Jamie. Moving to the next question. So how important was the integrated design? I think, Esther, you mentioned in like the weekly meetings and how you were changing this architectural design, and how much do you think that added to the cost versus how much it saves to reduce the passive house premium?
Yeah, so I guess it's 2 questions. I don't think this would be a certifiable building if our team weren't integrated. I think it just wouldn't have been possible. As to the costs, we haven't done like a numbers analysis on it, but what we used in design time and design fees at the front end, we didn't need to solve on the site at the back end. So I think it evens out in the end. And we also just had a lot less issues to deal with on site because we already knew where every single penetration was going to be. The panels came to site pre-drilled. Everything was kind of set up to construct almost, it wasn't completely like off-site manufactured, but it was almost like building a Lego box on site because we already knew where everything needed to go.
Right. Thank you so much for that. I think the next question is, was this a design build project? Is that like, did we answer this question through the presentation?
No, it's a construction management process. So the construction management was a design assist along with the Course Lab team, and then the construction manager tendered it to pre-qualified contractors for each subtrade.
Right. I was wondering with you and Esther, you started with this, that like house doesn't mean it's like coming from German, so it's like German language, so it means building. Are there passive house examples of non-residential buildings? And then kind of like a follow-up question, would it make sense for municipal facilities that are like office or like other type of buildings be passive house?
Definitely. I would say that in terms of what the YWCA needs to do, it's almost like a commercial building mixed with a residential building. So in Germany, I don't know if it's 100% complete yet, but it was very near completion when I checked last year. They have a passive house hospital. There are many, many schools in Austria that are passive houses. There's a whole, it's a community called Valbahn in Germany, which is almost a complete passive house community where the community center, the different housing units, everything is passive house. So the passive house standard is really, although we sometimes, like Sarah said, the complexity is only a perception. To us, sometimes it feels very complicated in Canada, but it's been proven and tested in many climates across the world. I mean, there are passive houses in Australia and New Zealand. There are passive houses in Brazil. So it's really applicable to any climate, any building type, and any scale. It actually gets easier the bigger the building gets, because they focus on this usable floor space, the TFA, the treated floor area, and they use that as a metric. So it becomes easier to achieve passive house the larger your building is.
Right, thanks. I will continue with the questions, but I'm just gonna launch one poll for everyone that it's still with us. Are you aware of any other net zero passive house projects that we could share with the network? So it's like, if you have interest in any other example and projects, then let us know so we can provide this to you. And then I'm gonna move to the next question, which is, did you need a backup heating for very low temperatures where the heat pumps aren't effective? And what kind of heat pumps, I guess, is the question.
And would we use water heating in the future? So it's kind of a double question. Looks
Right.
from Alan, perhaps. So I'll answer the first question. Is currently available air source heat pumps for water heating? Would you consider something else? I think we would. What we weren't thinking about very much as a mechanical industry in 2018, 2017 is embodied carbon. And so, not to say that that we wouldn't use an air source VRF system, but we would test it with other air source heat pumps that are now available that were not available at the time. So we didn't have a lot of choices in terms of system type at the time that were, really, it was like considered to be kind of future technology at that moment for water to air heat pumps. And then in this particular project, we oversized the condensing units so that we do not have a backup heating strategy, or we don't have a backup heating system. Like there's no electric boiler, for example, which is what you might see, or even some other kind of heating system. We didn't need to do that because we've compensated by the sizing strategy with the VRF units. And like I was saying, we're dumping exhaust air into that plenum. So even when it's minus 25 Celsius outside, you're stealing air coming out back from the building at maybe 20 degrees Celsius or something, and blending that in so that you're not really seeing the full outdoor temperature in the coldest times. I'll stop there. Probably.
Thanks. Moving to the next question, which is, can you clarify if balconies were considered for the building? I don't know who can jump on that one.
I don't know if Sarah knows. I'll just give a quick passive house thing to that. Is I don't know if balconies were considered or not. We have not yet done at KMAI a passive house with balconies, because when you do a penetration like that to your envelope, if you think about the wall and the balcony is essentially cantilevered off the structure where it connects, you have to provide some sort of mitigating strategy, because the balcony essentially takes the heat from that wall that's inside and sucks it to the outside. And that's a very big thermal bridge. So I don't know if they were considered for this project. I know there's a very large amenity space with outdoor space on the roof as well. So maybe Sarah can speak to that.
So I'm not sure, honestly, but I don't think it's been considered to have balconies anyway. Because exactly like Esther said, there's a big backyard available. So there's a backyard on the main floor, just outside the building, and it's secured. And it's also on the sixth floor rooftop. There's a terrace there, especially for the tenants. So I don't think we ever consider having balconies anyway.
Thank you.
Sorry, just to add to that as well, the windows in the residential suites are pretty much the height of the wall. So they're very, very big. And that I think allows for bringing that view or the outside kind of in to the building as well.
I think that's the next question. If I'm reading it right, is it openable? I think that's what they want to say.
Yeah.
Yeah,
and Sarah, they're all operable. I'll let Sarah speak to that.
Yeah, so yes, we can open the windows, and if we could change the design of the windows now, we would do it. So I know it was also because it's a passive house design, so the windows couldn't be like the operable window couldn't be smaller than the one we have because of the thermal ridges, but they are very, very heavy. So it can be challenging to open or close the windows. But they are huge though, and it's beautiful, I have to say that.
That's so nice, and I like Sarah. I like your comment when you said that the building is very quiet, because I do live in a on the main road, and it can be pretty. I can hear the traffic from outside.
Oh yeah, it's super quiet. Like even like on the corner of Ottawa Street and I think it's Dunsmuir, the street on the corner. So there's like buses there. There's a lot of traffic. If the windows are closed, you can't hear anything. We actually had complaints from a tenant because she can hear the dampers opening and closing in the same, right? And you never hear that usually, right?
Right. They're like last minute 2 questions that came. Is it okay, Esther and Jamie? I think they're like more technical. What is the window to wall ratio?
So if you give me a second, I can pull it up.
Yeah, that's a very specific
Yeah.
question. Well, like you don't need to.
I would say it's less than 40%, but I don't know the exact number. But it's under 40% would be a sort of design target that we would have used in the outset. This next question looks like it's for me. It's about future climate projections for designing the HVAC system and extreme heat events and cooling capacity in the future. I don't remember doing that for this building in 2017, 2018. Certainly it's something we would do now. There's been lots of evolution in sort of design thinking. You know, we mentioned embodied carbon. I think looking at like equipment and using refrigerant-based equipment, and also this category of sort of forward-looking, maybe using different types of projections for future loads. We weren't, I'll just be honest, we weren't as sophisticated in this category at the time. So this is something that's evolving, and we would definitely do this today, but I don't think so.
Right. Thank you so much. I wonder, most of our the audience is from municipalities, and I was wondering, maybe Sarah, just for the last 2 minutes, what like would it? I'm guessing that this funding that you're talking, it's more for like the social housing. So the funding opportunities were for like if you are to build like for non-for-profits and for like social housing, but without the funding, would it still make sense to go passive house just because of the cost? And you mentioned that the premium is 3%, but then you said that it's like 3 to 8. Would it like go even beyond that without the funding opportunities? And if there, and please jump and let me know if there are funding opportunities beyond the to be affordable housing.
Well, I guess it depends what type of development you want to do. So the YWCA, like the development are like fully affordable. So there's no market rental unit, right? So then we have to be very careful of the investments that we do. So the capital cost increase can be too high, but there's like other nonprofit developers that can have like a few market rental units in their development. So then for them, it's easier to offset the cost. In terms of funding sources, so the city of Hamilton is actually helping when they can. So there's not like a source of funding, like there's no program that you can apply for, but sometimes they have some money available and they can help. because the CMHC co-investment funding, has the name said it, you have to have a co-investor. If not, there's no point of applying. And then there's also provincial funding. There's not much currently, but who knows? It can change. So yeah, I guess it depends, like I said, on the type of development that you're looking for.
Right. Thank you so much. We are just on time. It's 2 p.m. ET time. Thank you so much, Sarah, Esther, and Jamie, for this. Thanks for everyone who joining us for this webinar. There was a question. Yes, we will be sharing the presentation and the recording maybe early next week with everyone that registered. And with that, we are concluding our webinar. Thank you and enjoy the rest of the day.
Thank you.
Thank you.
Thanks, everyone.